Can't help but think about a good cup of coffee every time you think of the sip protocol. At least that's what happens in my mind. I am a coffee drinker, although I'm about to go on one of my hiatuses, and let me just prepare you in case you go on this hiatus, just so you know what to expect, because I've gone on this twice now, and it's about to happen again. So what happens if you're a coffee drinker is you meet somebody who's not a coffee drinker or who's been an ex-coffee drinker, and they're like, "Oh man, since I stopped drinking coffee, like the sky is blue and the trees are green and my life is so great and I feel great all the time and like I have a six pack of abs." I mean, it just goes on and on and on, and you're like, "Man, maybe I should stop drinking coffee too." And so what I'm telling you is I'm just preparing you because I'm about to do this again, and I know what's going to happen. So what happens is you're right here, right, and you stop drinking coffee, and you're like, "Oh man, I'm so tired." And then like day one, day two, like a week goes by, and then you're like, "Okay, I'm kind of free from coffee," and you just kind of level out. It's not, the trees aren't greener, the sky isn't bluer, you just feel normal again. You're not tired without not drinking coffee. And then another week goes by. I mean, it never for me has gotten to that point of like, wow, I feel, like the six pack of abs still hasn't happened. But what inevitably does happen, this is how the cycle begins again, is I'll be normal, and then, I mean, how do you not drink coffee when you go out for a meeting at Starbucks or something? I mean, you go there and they're like, "Oh, well, we have a blue tea for $9.99, or you can have a cup of drip coffee," and you're like, "Oh, I'll just have a cup of coffee," right? I'm here at Starbucks, and so what happens then is I'm at this normal state, and now it's like, wee, I'm the sky is purple, I'm flying high, and I'm staying up till 3 in the morning, which for me, I know some of you are like, "Oh, well, that's horrible." No, that's great, because I'm like, okay, the kids are asleep, I can get so much done. I love those kind of nights. And then I'm like, coffee is the greatest thing, and so that goes on for a couple days, but then that starts going, so then you level out again, right? You're back sipping your coffee until you meet one of those people that guides you or misguides you into giving it up. And I just met one of those. So this is the coffee cycle, which I'm adding to the SIP protocol as bonus information, not on the certification exam. So as for SIP, we're going to talk about the same three things: the architecture, the call flow, and how to configure it. So after that, every slide is going to have somebody drinking coffee on it. So why is SIP special? What makes this protocol special, maybe over H323? So we saw the advantage of H323 is that it's got history. It's widely supported. It's well known. It's decades have gone by with H323 to where development has really ceased, and it's reached a point of stability. Not so with SIP. That's the drawback of it, is it's still an evolving standard. That's kind of an ever-changing thing, and different vendors implement it differently. It's just newer. I mean, even though you look and you're like, what, wasn't SIP created 14 years ago? Well, yeah, but it's just it's gone through too many revisions, and you also have to realize with SIP, you're bringing together an industry that has always been proprietary. I mean, PBXs, they've always had their own proprietary world. I've got my digital phones, and Lucent phones only works with Lucent PBX, and all that kind of stuff. So that's why this has been such a hard standard to nail down. But it was created by the IETF, so let's talk about some of the advantages. Why is that important? Well, that's the same standards body who created these protocols. And the neat thing about that is it looks and feels very similar. I think I mentioned in an earlier nugget, probably way earlier in the series, like for example, when you go to a web page, I don't know if, well, I think everything hides it nowadays. Like let me go to let's go to flugel.com or something. Flugel. I'm just trying to think of a site that wouldn't be there. Flugel, of course. I'm googling Flugel now, or maybe how about this? I go to let's go to cbtnuggets.com /blah.ht. I haven't quite gotten used to this keyboard yet. .htm. There we go. And so right there, you see, sorry, resource cannot be found. I just made up a thing. So you get this 404 error. So it's kind of nice to go, okay, I'm used to seeing that. And you're probably like, well, yeah, that's you see that all the time. Well, the beauty is you're in SIP, you dial an extension that's not there. Guess what you get? I know you guys. 404 error. You get like, okay, I can't find that extension. Or, hey, wait a sec. I'm going to be redirecting you to a different web page. You got those messages in your browser before, right? Well, same thing in the SIP world. They have a redirect server, and that all uses 3xxx series messages, which are all redirect. OK messages are 2x. I mean, so my point is that the same standards body created it, and they created it in such a way that it really has the same look and feel as everything else. Now, unlike H323, it uses text-based ASCII communication. So it's very easy for you to read. So, when you're doing a debug of H323, you might be matching, what does code 000159 mean to a guide and go, oh, that's the connect message, one of those kind of things. Whereas with SIP, you're going to see like ringing is one of the messages, invite is another message. So very, very plain English. Now that it has an inherent drawback. If you're not using binary encoded communication, it's not as efficient for a computer to process. So it's a little bit of a trade-off, I would say, with today's processors, not much, but you're essentially trading off a little processing time on the computer side to make it a little easier for humans. Now, SIP does have easy loop detection, meaning in the header information is embedded a lot of the number information, whereas with H323, it doesn't have some of that information in the header. So you could, if you point a gateway to another gateway to another gateway, you could end up causing a loop in the H323 network with your voice calls. It's not anywhere near as serious as like a routing loop or a spanning tree loop or something like that, but there's no inherent protection in H323. SIP is more efficient. And H323 maintains state information for every call, which makes, for instance, the H323 gatekeeper a potential bottleneck. That's why we have to add multiple gatekeepers. Whereas with SIP, you can have the server say, okay, I'm going to have you go over there, and then I'm done. I step out of the call. I don't track that information. Now, again, in that is an advantage because SIP servers can scale a little more than an H323 gateway, but a disadvantage to where you can't at any one time just go on to a SIP server and say, "Oh, show me all the active calls," because depending on the kind of SIP server that it is, it may just say, "Well, I don't know. There's nothing from what I know because I don't keep track of that information." Well, now let's peel back a layer and talk about a little architecture of SIP. SIP is really just a signaling protocol. That was its goal. Whereas when you look at H323, it really had audio-video conferencing in mind. So with SIP, they're kind of like, well, it is a session initiation protocol. That's what it stands for. So we start and end sessions. Now, most people use it to start and end audio sessions or even video sessions, but there's no saying that it's limited to that. You might have SIP, for instance, starting and ending a data transfer. You can have SIP start and end maybe a television conversation. I mean, here's the vision, by the way. Here is where things are going. If you haven't seen it yet, everything is being made compatible with networks and internet connectivity. I mean, if you haven't seen in the last few years, all your television sets are online, which sounds weird when you initially think about it. And then you're like, oh, wait, well, I get my movies and I get, you get like Apple TV. You've got cars that have internet connectivity as they drive. You have refrigerators and microwave ovens that Maytag sells. I kid you not, that have network connectivity to allow the Maytag repairman and the repair shop to run diagnostics remotely on that so they can bring exactly the correct part. I mean, just weird stuff, where everything has network connectivity. Well, with SIP, you're going to be able to start and end sessions with any of those. So what does that mean to you? It means communication everywhere. To where you'll be sitting there watching TV, and all of a sudden a little head pops up in the corner saying you've got an incoming call from your mother, and you okay, hang on, pause the TV, which is coming over an IP connection anyway, and then your mother starts talking on the thing, and she happens to be using her cell phone, kind of like an Apple FaceTime kind of thing or Skype on her cell phone to communicate with you. To where, I mean, do you see it? To where all communication mediums bridge into ones. I would foresee that someday phone numbers will be a thing of the past, because with SIP, your addresses look like emails. I mean, that's one of the again, back to the standards body, everything looks the same. So for instance, I might have a address that is jeremy@home.com. Actually, that was, if I can brag for a moment, that was actually my first email address. I was on the beta test area for cable modem technology, and they had this at home, and I actually had the email address for many years of Jeremy at home, and I would tell people, they're like, "No way, that's awesome." So initially, when you look at that, you go, "Oh, okay, well, that's an email," and you go, "Well, nope, that can actually be a SIP phone number." SIP, the way the standard works is you could have something that look like that. You could have, I mean, you could even have 1-480-555-1111, which may be a traditional looking phone number at home.com or so, at quest.net so what I foresee happening is, someday phone numbers are going to be gone, and we just have these addresses where I say, "Hey, give me a call at jeremy@home.com." That's going to be a normal thing that people say, right? And people go, "Oh, okay, well, I'll call you there." And so they call, and I actually associate, here's my jeremy@home.com. I associate my television, which I never watch, so that probably wouldn't be useful, my cell phone, and my home phone, and my car with that SIP address. So when somebody calls that, all those devices ring, or let me know in some way that I have an incoming call, and on whatever one is convenient for me, I pick up. Now tell me that's not cool, like some kind of, I don't know. It's funny because I'm like some kind of Star Trek episode, but at the same time I'm like, well, nowadays it's becoming norm. It's becoming the norm to see stuff like that. Okay, so what is the architecture of SIP? SIP has the following goals. Being a signaling protocol alone, it number one determines the location of an endpoint. So when I call Jeremy at home, I want to know that that television is registered as a possible endpoint for Jeremy at home. Determine the media capabilities. That's like, for instance, what codecs are supported. What codec does that television use when it can communicate with whomever is calling? Determine the availability, to where I can be watching my show and I say, "I'm sorry, I don't want to talk to you right now. Let me ignore," and it returns and says, "Sorry, that user is not available." Or I answer and it says, "Okay, that user is available. Let's connect them." Establish the session, which that's what we know and love of these protocols. And then, of course, by the time it's sent down, we manage the termination or a transfer, which in essence is a type of termination where I'm passing a call from one to the other, and so on. So when you look at SIP, it's just something that it's like a manager, right? A manager that doesn't really have any skills per se in what they are managing, but they really know how to get stuff done. They can say, "Okay, I need you because you guys have those skills. Go work on that piece of the project, and you go do that piece." And so they manage. That's what SIP is. Now, every SIP client is broken into two pieces. User agent client and user agent server. So when I look at this guy, it's a phone. It is a user agent, but it's actually always broken into those two pieces. The client is the one that starts the calls. So for instance, if I want to make a call from here, I just became a user agent client. And I decided to call this thing, whatever it is, instant messenger, it's Skype, it's whatever, because again, almost everything supports SIP as a signaling protocol. And so I place a call to there. Well, he's a user agent, but I'm invoking the user agent server. And if you think of how clients and servers usually work, like, okay, there's the server I go to a web server, right? It's responding to my request. So in the same sense, I've got this user agent client. He's the one making a request, placing a call, and he's the one responding. But if they hang up and then this guy calls back because he forgot to tell him something, now he becomes the user agent client and he becomes the user agent server. So both of them, it's kind of like if you place and answer calls, you have both technologies that you use. Now, behind the scenes, there are many servers that can manage this, and I drew this up because it gets confusing. You'll see if you read the standard, they're like, "Oh, well, you got this redirect server and that does that, and you got the proxy server and it does this, and if you read the standard, there's all these servers everywhere. And everybody's using these servers for everything. So you're like, well, do I really need 9 servers to run SIP? No, you can actually combine all these functions together in one, and maybe even not even use some of them. So let me talk about them. First off, I'll start here. A redirect server. You can have a redirect server that really just takes incoming calls, I don't know why I'm writing redirect. Takes incoming calls and does redirection with them. So it says, hey, I want to place a call to 1101, or I want to place a call to Jeremy at home, or I want to place, to whatever you're trying to call. And the redirect server says, hey, buddy, you need to go over there, and that will be the endpoint establishment. He's not taking responsibility for it. He's just saying, I know where he is, because I happen to be linked to a location server, by the way, with a location database. Location server is just a server that holds the database containing where all these endpoints are at. Right? So the redirect server looks it up and says, oh, okay, well, they're over there. So you go over there, and it points it over there. Now you might say, well, why is that such a big function? Well, the neat thing about a redirect server is it's very low resources, meaning you can get a lot of capacity out of one of those with very low resources because it's not really taking responsibility for anything. I don't know why this comes to mind. Remember when you were a kid and what was this? I don't even know if I can remember it now. Where someone would say something that was mean. They're like, "You're, I don't know, silly or whatever," and you would say, I don't even, I just remember like it bounces off me and sticks to you. What are those silly things you say when you're a kid? Like oh no, that was it. That I'm rubber and I'm glue. Wow, that's weird that I remember this. I'm rubber and you're glue. It bounces off me and it sticks to you, right? You say this little shindig. So that's the redirect server. So, this is like he's rubber and the endpoint is glue. It bounces off him and I have to now take responsibility. That's where the little rhyme breaks. You get the point, right? So registrar server. Registrar server does registration. I know, stroke of brilliance to put that statement together. So the endpoints themselves, so I've got 1102, 1101, as you configure them, they can come up to a registrar server and say, I would like to register my endpoint with you. Just so you know, I'm 1102. I've got this IP address. And if anybody asks for me, you can, record this information in the database. So this is where it gets difficult because you're like, okay, so the registrar server puts it where? In its own database? No, it goes in the location database. Okay, so a registrar server is a location server? It could be. Most of the time it is, but it doesn't have to be. You get the point why it gets so confusing? These roles, and that's why I put them all, I just showed them all as different databases, because you can combine all of these functions into one server. You could have one subserver doing all of this stuff, and a lot of people do, and most people call that a proxy server. A SIP proxy server is what you will most commonly find as like that. This would be like your call manager, if you will. Even though we're not talking about call manager specifically, and Cisco actually makes a full SIP proxy server that's totally different than call manager itself. But this is something that can get things done. Now that the functions of this are up to you. I mean, but you could have this guy be a registrar server, and it just the name proxy says I do things for people. I do things for clients. So when this guy comes and says I want to register, he will act as a registrar server and put it in the database. When this guy comes and says I need to make a phone call, where's this guy at? He can look in the location database. So he kind of acts as a location server. He can then redirect and be a redirect server. So or he can take responsibility and he can set up that call like a proxy server does. That's where the proxy name comes in and says, okay, I'm going to set up that call for you, just like H323 did with that gatekeeper. Make sure everybody connects. Everybody good? Okay, good. You guys can go ahead and talk directly using RTP. So these servers, you'll see them all over the place in SIP documentation. And just know that they can be all one device or they could be separate. The call flow of SIP is almost my favorite part because it's so human in how it talks. It's so plain text. It's like if two humans had phones plugged into them somehow and they wanted to make each other ring, this is how they would do it. So first off, two different modes that SIP can run in. We've got delayed offer and early offer. Most deployments use delayed offer. So we've got our voice gateways with the analog phones plug in. So let's say we've got two dial peers set up that are configured for SIP. I'll show you how to do that on the next slide. This guy is 1001 and he's calling 1002. So the call goes out. Message goes this way as an invite message. Like, hey, you're invited to have a phone call with me. And by the way, that immediately makes this voice gateway the user agent client and this voice gateway the user agent server. Notice I labeled the gateway because the phones are analog phones. They don't know anything about SIP, so the gateways are assuming those roles. Now, from there, this one comes back and says, oh, sure thing. I'm going to send you a 100 message trying. I'm trying to make this call work. Now, what's with the 100? Well, if you think to HTTP standards, 1xxx messages are informational. So it's like, hey, I'm just giving you some information. I'm trying to make this call happen. And immediately it will be followed up. Oh, my line got a little crooked there. By a 180 message, which is going to be ringing. Again, it's a 100 series message. It's just FYI informational. The phone is now ringing. And that's what this gateway now knows to go brrrr and play that ringtone for the calling party. So once this guy goes, oh, there's a phone call, click and opens the line, he sends a message that is a 200 series message, okay. And if you were to open a web browser and open Wireshark at the same time and go to google.com or something and capture all those packets, you would see at some point in there an HTTP 200 series message meaning, okay, I got your request. Here's the data that you were looking for. So same thing here. Okay, we're connected. Now, this guy sends an ACK. Saying, okay, I got your okay. We are going to communicate and talk and let the conversation begin. This is where RTP steps in using whatever codec you've chosen. Now, that right there, the word codec, implies that somewhere in there they had to negotiate it. But it seems so simple. Where did that codec negotiation happen? Well, it depends on whether you're using delayed offer or early offer. That's really what is represented by that. The original way SIP was developed was a delayed offer, to where you would send the invite message, it would say trying, ringing, and then as part of the OK message, like the person lifts the handset, it sends what's called an SDP packet. That is a session description protocol. You might write that down, embed it on your forehead. Session description protocol. That is the protocol that's used to communicate information during a call. Like in this case, it's going to be media offer. So it's going to say, hey, I would like to use the G711 codec. This guy says, ACK, and I agree. You know, here's my answer. And by that's also an SDP packet right there. So right there, that is, do you get the idea why, again, it's very plain English. Why do you think they call it a delayed offer? Because it doesn't happen at first. You send the invite, you send the trying, and that immediately hints as to what the early offer means. The early offer means I'm going to negotiate the protocol before the call is actually established. Like this is going to be just like H323. Like if right there you have a mismatch, you're going to hear ring, ring, brrr on the other side. And as soon as they lift the handset, you would get that because now we have a codec mismatch, and we didn't know it until then because it was a delayed offer. Early offer, there's different ways of doing it, but early offer embeds the SDP media offer packet in either the invite message or in the ringing message. So you could have the SDP media offer right here, where as soon as the invite message goes out, and again, it depends on what flavor of SIP. Remember I said it's developing and there's different ways people do different things. This is one great example of that. Some of them do it in the invite message, and by the way, Cisco supports both. So if the other guy receives it immediately, he's like, whoa, I don't support that codec. The beauty of early offer is the phone never even rings. It's like, hey, we are not compatible. There's no point to even continuing this conversation. Let's stop right now. The other place it can embed it is inside of the ringing message. So when this guy does the ringing, it depends on which side you want to initiate that negotiation. Right when this guy comes back and says, the phone is now ringing and you have to use this codec. Does that make sense? So if that's the case, then he's going to reply with the ACK, and that'll say, okay, inside of there, I will answer, and that will be what codec we end up using. So both of those are considered an early offer. Okay, well, let's wrap up by looking at the core configuration of SIP, and I do mean core, as in I'm actually holding a book in my hand that Cisco Press kindly sent me called SIP Trunking. It's pretty. I think it's a really good book. It's very well written. It's 300 pages, which is for a Cisco Press book really skinny. And so they go through. I'm just looking at the table of contents, kind of an overview of IP telephony, trends in IP telephony. Essentially, this book is for organizations that are trying to move from traditional phone lines over to SIP connections. And I'm just flipping through this thing, and I mean you've got a lot, a lot that you could dive into in depth. Of SIP, but that's not what CVOICE is here for. Close this book. CVOICE is here for really kind of the overview. Like you could dive deep into H323. You could think of it like almost like a CCNA of voice protocols, to where it's like you now know enough to work with these, but know that as you begin exploring them, you will find more. So this is the core of what you will get running. First off, how do you make your voice gateway into a user agent? Well, first question would have to be, why would you do that? Well, let's say you've got all these different voice gateways that are CME servers, or the new word CUCME, if you want to go with the nice long way. So you got all these CME ones that are supporting maybe 20 phones at each office out there, and you want to start connecting them all together. Well, before long, just like we saw with the H323 gatekeeper, it becomes madness to try and get all the dial peers straight as you add more and more offices. So what you might do is set these up as user agents and do set up a registrar server, to where they will go out and register all of their 20 extensions with that registrar server and whatever POTS dial peers they have. So now you have this one global database that's built. Go back to the location database and then all the different servers that can give you that information. And it's dynamically built for you. So here's how you would do it. I would go to, there we go, my router, and go into global config and do SIP UA. And that's where I can go and type in a registrar and what the IP address is of the registrar address. Now, let's see if this one does it. It seems like Cisco is getting lazy in some of their command line coding, to where they just say word. But sometimes, I haven't tried it with this one, so let's just see. Good. See, so they just say word, and I'm like, come on, Cisco, you're a command line company. Give me a little more than that when I hit the question mark. So this is the format that you need to type it in. So just like the dial peers, you would type in IPv4 or DNS for the registrar server. But I'm wondering, how come you don't tell people that when you just get word dumped at you? So you have to know, I need to type in registrar IPv4. I can't just type in the IP address and then do 10 whatever that registrar IP address is. And as soon as you do that, the gateway automatically goes out and registers all POTS dial peers, as well as CME I'll say IP phones, skinny managed devices that are registered with it. It goes and registers all those with the registrar server. So now the registrar server knows what extension are available for there. Now, usually you'll have authentication set up as well. So we would have an authentication username of, this is CME1, and a password of, ASDF. And so that would be required by the registrar server, because you don't just want to leave it wide open where anything can come and register. So that adds the authentication to it. Now, this, by the way, is really handy. I should save this, but I was going to save it for the summary. This would be a cool thing for you to do. Go out to VoIP.ms or Vonage. No. Scratch Vonage. Sorry, Vonage, you just got wiped from the list. ViaTalk.com. Both of those organizations allow you to register your Cisco router or whatever SIP endpoint you have with them directly. Now, the beauty of VoIP.ms is it's free till you start calling. They just have, you just put a credit card. Matter of fact, I think you can even sign up without a credit card. But you put a credit card on file and you just pay per minute, like a penny or 2 pennies or something like that per minute, or depending on what area of the world you're calling, you get billed appropriately. But the beauty of that is it gives you a registrar server where you can actually link your Cisco Voice Gateway to it and make some phone calls out on the PSTN. And these guys, by the way, are technically known as ITSP. Internet Telephony Service Providers. Via Talk, you don't get the per minute charges, but you end up paying, per line or something like that. Whatever, $19 a month or whatever plan you sign up for, $10 a month. It's pretty cheap. But both of those allow direct SIP connections, which is kind of fun. Dial peer configuration. So registering with the server is great, but you need to start saying, well, here's what phone numbers are available, and that's where the dial peers come into play. Dial peers are just like we've always done, so I can go in there and do dial peer voice 50 voice over IP, session target IPv4, where whatever we'll say that the proxy or whatever ITSP endpoint you're going to connect to. And if you sign up with one of those guys up top, they'll tell you what servers to use. They have servers all across the nation. You just kind of pick the one that's closest to you. And then you go in and say, well, the destination pattern, and that's where you use your dial peer skills from earlier in the series. 9 1 ... You know what I mean? You set up all your long distance peers, set up all your local calling peers, and then the key is to add in that session protocol SIP. That you can see it right there, the last one in that list. Now, one of the things that Cisco allows you to do, and you can see it here in the list, is they allow you in the SIP user agent to define a SIP server. Not cross it out, but define it. And the SIP server can then be easily used in all your dial peers, so you don't have to keep coming in here and typing in session target IP, whatever this IP address is. It kind of makes it a little more modular, and you can just make the change in one place. So here's how it works. I can do SIP UA, and I'll do SIP server. Again, same thing. Come on, lazy Cisco word. So throw some junk on there, and it'll give you the syntax that you can use. So you could go in there and say SIP server is actually DNS, whatever. We'll just say Kansas.voip.ms. And that will be now your SIP server defined. So now you can go under all of your dial peers, and instead of doing session target, get back there, session target IPv4 I can just do session target SIP server and hit the enter key. And now, for instance, if that SIP server ever had to change, I can just change it in one place, and it changes for all the dial peers instead of me having to go dial peer to changing every single one. So kind of handy there. Last thing is just some more global commands, depending on what kind of session transport and interface binding you want. So this is, as it seems, UDP or TCP. Which would you like to use? The default with SIP, most of the time, again, we're in this fuzzy standard world, is UDP. You'll see most vendors use UDP port 5060. But there are other vendors who will choose to use, because the standard supports both of them, so you get this big mismatch of what vendors support. Some will do both. Some will use TCP 5060. So you can go into this is the voice service mode. Well, you notice I put or dial peer. You could do it on a dial peer by dial peer basis by typing in session transport. And you can choose UDP or TCP. Or you can go back here, remember this mode, voice service VoIP, which is kind of the global commands for all voice services. And you can go under SIP and then do the session transport in here and select TCP or UDP, which affects the router as a whole. So the dial peer always overrides the global settings, so that gives you some flexibility there with connecting to different people. The last one is this bind. I can bind the signaling, the media, or everything, the signaling and the media, to a specific source interface or IP address. And this is, we're right at the perfect point. So I can type in bind and then choose what I want and what source interface I want it to come from, or what source IP address. Like if I want to use a loopback interface or something to that effect, I can do that to specify it's always coming from this IP address. And the reason that's good is because registrar servers will commonly say, I'm filtering based on, oh, excuse me, I'm filtering based on what source IP address you are. So I will only let you register if you're coming from the static IP address. It's extra security. And so you want to make sure to use that when you are registering. I am talkative today. I looked down. I paused right after the configuration piece right there. I was like 10 minutes. It felt like 3. Forgive me if I must be right here on my cycle. I'm coming up to the peak right now, about to explode or something. But nonetheless, SIP in all its glory. And I have, my typical, what did we talk about? What do I want you to do with it? We talked about the same, core 3 items of SIP: the architecture, the call flow, and configuration. But I'm more interested right now in letting you know what I want you to do about it. I kind of opened the can a little bit early on that last slide, but I want you to create the ultimate configuration to where if you've got your own little Cisco router that you're using to follow along, maybe a lab router or something, I want you to do it all. And what I mean by that is, number one, set it up for CME. At this point in the series, you've got that knowledge. Get some IP phones registered, or an alternative, you don't have some IP phones, set up some POTS dial peers and get some analog phones connecting on an FXS port. Then I want you to set it up with some dial peers, and I want you to trunk it up. I want you to set up a SIP trunk with one of those 2 providers, VOIP.ms. And by the way, they don't pay me to market, so if you've got a better one, go for it. These are just people that I've used in the past, and it's worked pretty good. Viatalk.com. One of those 2, I would, if money's an issue, just use VOIP.ms and pay a couple pennies just to make sure that it's all testing out okay. But that will, the beauty of this whole thing is with for instance, VOIP.ms or Viatalk, they'll give you a DID. As a matter of fact, with this guy, you can even say, I want a block of DIDs. I want a bunch of phone numbers. And you can do the whole thing at this point. You can put it all together, get some phones, whether they're IP phones or analog phones, get them registered with the registrar server, and I guarantee you're going to hit some walls there. That's why I want you to do it. You're gonna do it, and you're gonna be like, it's not working. What have I done wrong? And you'll have to do some debugs. You'll have to make sure that your Cisco router is compatible. You're gonna do some Google searches, and by the time it's said and done, you're gonna be like, man, I'm a stud or studette with my voice gateway skills. You can set up the whole picture at this point, which I'm pretty excited about. So have at it. I hope this has been informative for you, and I'd like to thank you for viewing.